Hello and welcome to another session in the series Programming Daily. Today we're working on drakon-renderer again. I made some progress since the last time, especially around my new layout algorithm. The last time I recorded, I showed sort of how the algorithm would start working. And we can see it here. We formulate this dependency plane, which is a list of icons. Then we extract the first column from that dependency plane. Then we move on to column number 2, and this is the new piece of code. From column number 2, before the column number 2 is formulated, we extract a new dependency plane that does not have the icons captured in the first sweep. And following the same pattern, going column by column, I'm hoping to lay out the whole structure of a diagram. It is very much work in progress. We haven't isolated any sort of coherent loop or a recursion mechanism. I just want to get a sense of what kind of pattern will emerge if we progress further in that direction of my new algorithm. So I created a number of very descriptive and meaningful functions, like for example ABC prime. And let me show how that would work. So since the last time, I think we did have the ABC, which translates the dependency plane into a list of positioned icons. This translates the first, this extracts the first column of positioned icons. Now I'm moving on to a more general function that takes any dependency plane and starting position X and Y for the positioned icons that we're going to isolate. And also it takes a collection of positioned icons that we've isolated in the previous step, so that the algorithm has a chance to detect which icon should be positioned in the current sweep. So to give you an idea what this ABC function does is previously we had this print first column, which rendered, if I'm not mistaken, something like no. Can't remember where I put it, but anyway, I'll try to render the first column isolated by the algorithm and the second column. So first column should be all the icons on this line. Second column should be all icons on this line, meaning hello world icon 6, icon A and B. Let me make it a bit larger. A and B. Sorry, hello world icon A and icon C, I believe. This is just a wrong description. Let's go back to the code and we'll see. So in the first column, let's compare the views side by side. it is a bit unwieldy to work with, but the algorithm sort of works. Already we can see a correct pattern emerging. So the first column is icon name 0 and description hello world title. There we should expect the dependent icon is icon number 1, which is the headline, which is this. Then we have dependent of identifier 2, which is hello world icon 2. Let me just demonstrate this. Hello world icon number 2. But this is not the most interesting bit. We've done it in the last session or during the last session. Today I'm mostly interested in how the algorithm would work if applied recursively or in a loop. And the second sweep of the algorithm should take care of these icons. And if you can imagine the dependency plane without all these positioned icons, the dependency plane would only contain 6 icons. 1, 2, 3, 4, 5, 6. And out of these dependencies, we want to isolate icon 6 first. So the algorithm works as so. It goes from the bottom to the top, and it is looking for first icon which parent is already in the list of positioned icons. So it won't be this, it won't be this, it should be hello world icon 6. Now, the current shape of my algorithm does not stop when it finds the first icon which parent already is positioned. It is taking all icons from the new dependency plane which parents are already positioned, meaning that the second sweep produces hello world icon 6 and hello world icon 4 because their dependencies, namely hello world icon 3 and hello world icon 2, are already added to the list of positioned icons. We're not necessarily interested in this. The reason why we only want icon 6 is that it should fall on one line, leaving the icon 4 path for later when icon 6 and all its dependencies in this sort of chain and in this chain are rendered. So this, to finish the introduction, this is the second column produced by my new algorithm. Sorry. And it should contain, well, it should contain only one icon, namely icon number 4, or identified as 4, but it contains 4 and 6 because, as I said, it just doesn't stop whenever it finds the first occurrence of an icon which parent is already positioned. It all sounds a little bit complicated, especially with function names being pretty cryptic, but I promise it will make more sense soon. Now, for this function to work fully correctly, we need to do two things. I noted them down as to-dos. To-do number 1 is that right now the positions of the positioned icons do not change. Well, naturally, icon position X should remain the same for the same column, but the icon position Y should change. So this should start at 0. That should be -1 or whatever icon height is. In our case, it's just -1. And it should decrease by the value of icon height with every subsequent found icon. Now, I think There is also a to-do number 3, but to-do number 2 is we only take the first found icon, which parent is already positioned. Yes, so instead of 4 and 6, we should only return 6 in this iteration. But there's also a to-do number 3. If you look at the diagram here, the second column, it does contain a Hello World icon 6, but it also contains other icons. Namely, as with the first iteration of the algorithm, the first sweep, all of its first dependents, namely this icon and this icon. We can easily add them shortly, but for now I just want to make sure that we have a sort of a starting point, a starting anchor added to the second column. So let's just mark a to-do number 3. We also want first okay, so without any further ado, let's maybe start with to-do number 2, because I'm a bit limited on time today, and I'm very curious how it would all look like rendered. So the question is, how do we stop when we find the first icon which parent is already present? I'm not sure if Haskell has a first function that that would work in our scenario, but I think fold R since fold R produces a collection, we're only interested in the last item of that collection. And let me just confirm if Haskell's function for that is tail. Last element of list. Oh, last. Let's see if this works. Well, obviously, last only returns one positioned icon. But if we, just for now, surround all of it in brackets, that should work. So that only returns 6. All right. That is good. But it would be better if we didn't use fold R and instead just extracted the first element only. I think this last will have to do for now. I don't want to overthink it. But in our scenario, let's do currently positioned icons plus the last. And here we should be able to rename this first and second column. All these names will most likely change, so I'm not paying too much attention to that. So here, if we render first and second column, we should see the first column plus icon number 6 plus connection to it. Let's see if that is the case. Oh, and that probably wouldn't work. Well, it would render something, but icon number 6 will not be rendered correctly or positioned correctly. Simply because this function ABC prime starts with y equals 0, where in fact y should be parents y, or depth, minus icon height. But this is easy to correct. Yes, it's 0. And also it shouldn't be 1, it should be the distance between icons. So, but we can easily correct this. Okay. And it is number 6. Now, what I'm noticing now is the connections are not rendered correctly. Yes. Sorry about that. Now we should see a connection, albeit incorrect. And here, this should be icon width plus additional space between icons. For now, let's export it. Let's open it again. Oh, that's better. It is not looking very correct, but at least the distance between the first column and the second column is correct. We're finally addressing that issue with the gap. Remember the old algorithm that we used to have? This gap is no longer here. Nothing else is correct, but at least we don't have a gap. It's fine. So here we need to correct a number of things. So first of all, I do not believe that we need to specify the y, because the y is going to be inherited from the parent, which is already positioned. So this function is parent lm. I think we should change to not return true or false, but to return a positioned icon or a maybe positioned icon. So here, instead of having an any, we should have a filter. So let's call it parents. And now oh, sorry. So here we can say off. Here we can pattern match. this handles the else case. And now sorry, this should be just X, and this should be Y. I believe. No. All right, let me debug this in silence. It looks like it's getting a bit noisy in my house. It looks like I will have to rework this function, but probably this is a good idea for another session. I'll get back to it. I feel we've made pretty good progress today. It's not correct, but we're getting there, and I see the end of the new implementation, new algorithm on the horizon. Thanks very much.